Okay, hello, this is section 12.3 video on trigonometric functions of general angles. So our objectives here are we're going to find values of trig functions for general angles, and we're going to use values of trig functions by using the reference angle. So let's start with a trigonometric function of general angles. So we're going to let theta be an angle in standard position. When we're standard position, the initial side starts at the x-axis right here, and it goes counterclockwise. Okay, so we're saying it's in standard position, and let this point P, coordinate xy, be a point on the terminal side. So the angle goes from here to here, so this is the terminal side. Using Pythagorean theorem, we can find R, the hypotenuse, right? If we make a right triangle, we have x here, y here, and we can find the hypotenuse by using, find R, the hypotenuse, by using Pythagorean theorem. All right, the 6 trig functions of theta. So right now we don't know sine of theta, so we're using this angle right here, and we're going to use y, which is opposite, and that y, the y coordinate, over r. Cosine is adjacent, which is x over r, and tangent is simply y over x, where x can't equal 0. Then we know that these are the reciprocal functions, so there's just a reciprocal of those. So here y can't equal 0, x can't equal 0, and y can't equal 0, because we can't have a 0 in the denominator. Okay, so they want us on example 1, they want us to evaluate trig functions given a point. So they said the terminal side of theta in standard position contains the point -3, -4. So what we need to do is we need to draw this out. So we, whoops, a little straighter here. Okay, so -3, 1, 2, 3, 1, 2, 3, 4 is right here. So remember we said some point xy, oops, I draw this very good, is on the terminal side. Yes? So we make the right triangle. So this is -3, -4, right? So my angle goes all the way around to here. Okay, so I can use Pythagorean theorem to find r. So -3 squared plus -4 squared is 25, the square root, so r is 5. So we have r equals 5. All right, so now they want us to find the exact values of the 6 trig functions of theta. So we know sine of theta equals y over x. So we said we have -3, -4. So this is my x, this is my y, and there's my r. So it's going to be -4/5. Cosine of theta is going to be -3/5. Write tangent over here. We want to write on the same line. Tangent of theta is y over x. So -4 over -3, which equals just 4/3. So then we do the reciprocal functions, and we don't drop the sign, we just flip them over. And secant of theta is going to equal to -5/3. And tangent, cotangent of theta is simply 3/4. All right, makes it really simple. So we're just using the right triangle. Now, quadrant angles. Quadrantal angles. What are those? Okay, so that's our first vocabulary that we have. Oh, let me go back to it. All right. So a quadrantal angle, by definition, is when a terminal side of an angle in standard position is on the x or the y-axis. So for instance, look at here. You've got, this is 0 degrees, so the terminal side is on the x-axis. This is 90 degrees, so the terminal side is on the y-axis. This is a 180 degree angle, so the terminal side is on the x-axis. And then this is 270 degrees, and its terminal side is on 270 degrees. Or, we already learned in the last section, we can convert these to radians by multiplying by pi over 180. And so they give you both the degree and the radians of each of those quadrantal angles. Okay, so let's look at this one. So the terminal side of theta in standard position contains a point 0.06. Find the values of the 6 trig functions. So what we have going on is we have 0.06, right? We said some point. So that's the terminal side. So our terminal side goes from here to here. Okay, here's the vertex. So we know x is 0 and y is 6, but this is also going to be r. So r is also 6 because it's 6 units from the vertex to the point. Remember, when it's not a quadrantal angle, okay, this point here is xy, 0, 6. And then the length of this, but we have a right triangle, so we use Pythagorean theorem here. Okay, that's my terminal side. My angle is from here to here. And then this is essentially my r as well. Okay, so it's 6 units. So now we know sine of theta is what? Y over r. So 6 over 6. And cosine of theta is 0 over 6, which equals to 0. Tangent of theta is going to be y over x, 6 over 0. Whoops, that's undefined. Remember, we can't have 0 in the denominator. So then let's do the reciprocal function. So cosecant of theta is going to be 6 over 6, or 1. And secant of theta is going to be 6 over 0. Whoopsie, that is undefined. So secant of theta here and tangent of theta undefined. But what about cotangent of theta? It's going to be 0 over 6, or 0. So we can't have 0. But remember, these two are undefined because you have 0 in the denominator. So when it's on a quadrant, whatever it is, this xy coordinate, this is going to be xy, and y is also equal to r. Okay. Now let's talk about reference angles. So trigonometry functions with reference angles, that's if we have an angle greater than 90 or less than 0. So we'll use a reference angle to find the value, the trig functions of that angle. So let's see. So it's a non-quadrantal angle in standard position. Its reference angle, theta prime, represented by theta prime, is the acute angle formed by the terminal side. So here we see the terminal side right here, okay, and the x-axis. So in quadrant 3, it's going to go right here. If it's in quadrant 2, then the reference angle is going to be right here. I'll show it to you in just a second. And so on and so on. So the rules for finding the measures of reference angles of theta between 0 and 360, or between 0 and 2 pi, are shown. So let's make it more clear. So if you're in quadrant 1, that means it's less between 0 and 90, then theta prime, which we use to represent the reference angle, is also equal to theta. So if it's 30, the reference angle is 30. So here's the terminal side, and you go to, so you're going to take it and go to the x-axis, no matter what. So let's use blue. Okay, 30 degrees, or let's call it 45 degrees. Okay. And then we come down to the x-axis. So this, between the terminal side and x, is your reference angle. If it's in quadrant 2, okay, so here's my angle. It's in quadrant 2. Then you take its point, r, and go down to the x-axis. So this is my reference angle here. If it's in quadrant 3, okay, there's my terminal side. So you go from R to the x-axis. That is my reference angle. If it's going to be in quadrant 4, you're going to go all the way around to here. This is my terminal side, and you take it up to the x-axis. So between the terminal side and the x-axis, that is going to be my reference angle. Okay, so if we look at our picture, quadrant 1, they're the same. Here, it's going to, in quadrant 2, it's going to be 180 degrees minus theta. So if theta is 120, it's 180 minus 120, or pi minus theta if it's in radians. If it's in quadrant 3, to find your reference angle, you take theta minus 180, or theta minus pi. If it's in quadrant 4, you're going to take 360 and minus theta, or 2 pi minus theta. So this is your general formula for finding the reference angle, if you're not sure how to do it. So if the measure of theta is greater than 360 or less than 0, we use coterminal angles with the positive measures between 0 and 360 to find the reference angle. So, for instance, 210, they want us to sketch each angle, then find its reference angle. So they want us to sketch 210 degrees. Well, 210 degrees, I know that here to here is 180, so 210 is going to be here. Okay, so I'm going to make it up to the 90 degree to the x-axis. Remember, this is the x-axis. So, because it's in quadrant 3, I'm going to take theta and minus 180, and I'm going to get 30 degrees. So, this right here is 30 degrees, and that's the trig function that I would use to find this is y, x, and r. Okay, now let's look at this next one. I don't like radians, so -5, 4 over pi. So first of all, I know it's negative, so it's going to go counterclockwise. So you're going to start here, and you're going to go to -5 pi over 4. Well, where is that going to be? That's going to be all the way here. Okay, so -5 pi over 4. If you convert this to degrees, you're going to get 225 degrees. That's how I knew it was here, because from here to here is 180, and then if I subtract 225 from 180, I get that I have 45 degrees here. So this would be my reference angle. So, but they didn't do that in the book. What they did is they said, okay, I'm going to add 2 pi to get a coterminal, right? You add 360 or 2 pi. So 2 pi is the same thing as 8 over 4, because 8 divided by 4 is 2, which gives you that from here to here, right? Because if you go all the way around, it's 2 pi. So if I wanted to find what this angle is, it's 3 pi over 4. So this is 3 pi over 4, so in order to get this reference angle, because it's a quadrant 2, I take pi, which is 4 pi over 4, minus 3 pi over 4. I'm just doing fraction rules. I converted pi and got a common denominator of 4, which equal to 4 pi over 4. That's how I got that. When you subtract it, you get pi over 4, or 1/4 pi, which is the same thing. And if you convert this to degrees, you're going to get 45 degrees. Okay? So I always convert my radians to degrees first. Do it in degrees to figure out what these values are. And then I go back and then you can switch it to convert 45 to radians if it's asked in radians, or it's given in radians. So basically, you had to know where 5 pi over 4 is. You got to know your fractions really well. That it's right here. And you know to get here, I just subtracted take the absolute value and subtract it from 2 pi, so I know that this is 3 pi over 4. Or add 2 pi, same difference. But that's the angle here. Remember, they're coterminal, so have the same terminal side. So in order to find the reference angle, it's in quadrant 2, I do pi minus theta, which is 3 pi over 4. Okay, now, so you can use these trig functions, and it's going to take practice, especially with the radians and the negatives, to evaluate trig functions for any angle using the reference angle. However, we have to know what sine. So remember, we said the sine is what? Y over r, and cosine is x over r. So if you look in quadrant 2, all right, so if we look at our trig functions, we have sine, cosine, tangent. And so the cotangent, so these are just reciprocal functions, right? And so we said in quadrants, if we look at it this way, we look at them as x comma y. Right? So in this quadrant, x and y are positive. Here, you go left, which is negative x comma y. Quadrant 3, we're going to get negative x comma negative y. Quadrant 4, we're going to get x comma negative y. Right? If I pick some points in here, these are the signs of x and y. So if I know sine is y over r, x over r, and this is y over x. Okay, so we look for sine in quadrant 1 is y, so it's positive. So sine is positive here. They're all going to be positive in quadrant 1. Okay, in quadrant 2, sine is positive. That makes cosine is negative. And so tangent is going to be negative because positive divided by negative is a negative. So obviously, these are just reciprocal, so the signs don't change. So if tangent is negative in quadrant 2, cotangent is negative. Cosine's negative, secant will be negative. Sine is positive, cosecant is positive. And then you go to quadrant 3, both x and y are negative, so both cosine and sine are negative, and tangent is going to be positive because you have negative y divided by negative x gives you positive. And guess what? Cosecant and secant are both negative, and cotangent is positive. In quadrant 4, cosine is positive, sine is negative, tangent is negative. And then you can figure out the reciprocal functions, or you can memorize this little chart. So remember, reciprocal functions will have the same sign as the reciprocal function. So sine and cosecant will have the same sign, and cosine and secant will have the same sign. So you can remember another little thing you can remember is all students take calculus. So they're all positive. Sine is positive, making cosine and tangent negative. Tangent is negative. Tangent is positive. So only sine is positive, only tangent is positive, and only cosine is positive in this quadrant. That's another way of figuring that out. Okay? Now, we can use the values of 30, 45, and 60 that we learned in lesson 12.1. So here we go. So we have sine of 30 is 1/2, cosine, blah, 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 and so on. So we can use these special values. Let's look at the next problem that they give us. This is find exact values of 240 degrees. So based on the reference angle, 240 is going to be, it's 180, it's going to be here somewhere. Correct? And we make the right triangle to the x-axis. So if this is 180, it's in quadrant 3, it's going to be what? 240 theta minus 180 is going to give me 60 degrees. So my reference angle right here is 60 degrees. And they want us to find cosine of 240 degrees. Well, I know cosine of theta is going to be what? X over r. All right. Well, this is 60 degrees. This is a special function. So if you go back to the chart here, cosine of 30 degrees is square root of 3 over 2. So cosine of theta is square root of 3 over 2. And we know cosine is what sign in quadrant 3? It's going to be negative, so it's negative square root of 3 over 2. It's going to be, oh no, I lied. Cosine of 60 degrees is 1/2. Sorry, got this right if you look at the chart. So cosine of 60 degrees, that's my reference angle, is 1/2. And it's negative, so it's cosine of 240 degrees is negative 1/2. Okay? You use a reference angle to find the value, and then you have to attach the sign based on what quadrant it is of the value that we're finding. So that would be negative 1/2. Now let's look at B. B is cosecant of theta equals 5 pi over 6. Oh, they want us to find cosecant of 5 pi over 6. Well, I know cosecant of theta equals 1 over sine of theta. Okay, so if we simply plug it in, so it's 1 over sine of 5 pi over 6. So first we have to evaluate this. So what is 5 pi over 6? Okay, so we start here. So I know that this is pi over 2, and this is pi, and pi is equivalent to, if I get a common denominator of 6, I get 6 pi over 6. So that's what 180 is. So I know that this is less, so it's going to be in this quadrant. So this is 5. This is where you know fractions really well. Or you can convert to degrees, which I think is easier, but we'll keep it this way. So that's your reference. That's your angle. But we need to find the reference angle. So I'm going to take pi minus that, or 6 pi over 6 minus 5 pi over 6 equals pi over 6. If you want to convert that to degrees, then you get 30 degrees. So my reference angle is 30 degrees. So I want to find sine of 30 degrees. Well, then we go back to our chart. Oops. Here. So sine of 30 degrees is 1/2. Okay, so but I want cosecant, which is 1 over 1/2, which is a reciprocal of that. So cosecant of theta, or 5 pi over 6, is equal to 2. And remember, sine is positive in quadrant 2, so cosecant is also positive. All right, so let's look at one more example. So the example 5, real world, it says, the swing arm of a ride at the right are 84 feet long. The height of the axis from which the arms swing is 97 feet. So we're saying from here to here is 97 feet. What is the total height of the ride at the peak of the arc? So they're saying this is our peak right here. And they want to know what this total length is. So we have to find this distance here and add it to 97. Well, they give us the angle. And they say it's negative 200 degrees. All right, so this is 180, which makes the reference angle 20 degrees. So now I have a right triangle that looks like this. I want to find this. I know this is 84, and I know this is 20 degrees. So I have what? O and R, or hypotenuse. So I'm going to use sine. So sine of 20 degrees equals y over 84. So then I use algebra and multiply both sides by 84. Okay, so then I put this in my calculator, 84 times sine of 20 degrees. Make sure you're in degrees. And I get y is approximately 28.7 feet. However, I went plus the total of 97. So I'm going to add 97 to this. 15. So it's approximately, oh, I added it wrong. It's 11, not 4. 12. So it's approximately 125.7 feet tall. All right, do the practice problems. We'll talk more about reference angles in class. Bye.